This is Remy with Case at JMU, and in this video we're going to be unpacking the Solar Challenge kit. So there is a default kit that people will receive that is not going to have the solar panels, the wire strippers, or this box, but the full team kit that you get when you are a first-time coach or you request a full kit is going to have everything you see here. So the first thing that this full kit is going to have are these solar panels. These solar panels are from Vernier, and they do have information on the back that tells you the wattage and how many volts it will produce in direct sunlight or in a really, really close lamp. It also says it on the package. So this is a benefit that you know what it can do, and that's really helpful. The reason that the default kit does not come with solar panels is that because in the Solar Challenge, you can use any solar panel to power your device. And I don't want to stifle your creativity or your possibilities by just giving you the same solar panel that everybody gets. And you can find really great stuff on Amazon or like Batteries Plus, find great stuff. So this allows you more freedom to go and find the solar panels that meet your needs the best. The multimeter is an important piece of the kit, either kit. And the reason the multimeter is important is because the multimeter allows you to get to know your solar panels. And I think this is a very first step that is really important. And so I'll show you how to use the multimeter real quick and how to hook it up to your solar panels and get to know your solar panels. Again, with these solar panels, there's not a lot of question because it tells you right on it how many volts and things like that, but it's great to get your students to also find that information using the multimeter rather than just reading the label. So in order to set your multimeter up, you're going to take the black lead and stick it into the bottom hole. Make sure you press it in all the way. And then the red lead is going to go right above it. Okay. So the easiest way to get to know your solar panel, you're going to go to the 20 range on the direct voltage side of your multimeter. And then you'll take one solar panel and connect red to red and black to black. And then at that point, even in this fluorescent lighting in my lab here, I'm getting about 1.76 volts of electricity. And if you cover it, it goes down, you know, things like that. So this is really important. The other piece of the puzzle is not just voltage, but you have to also understand the amperage or the current. And in order to do that, you have to go to the A with the line and the dotted line. That's direct current. And again, find your scale. The 20 milliamp scale seems to be pretty good in here. If you go outside into the sun, it's gonna go way higher, and you may have to go to the 10 scale. And if you do that without blowing up your multimeter, you need to move the red lead to the top hole, but only on that 10 scale. Again, in the lab, we're not gonna get that far, but in direct sunlight, the current gets pretty high and you may have to go there. Okay, so voltage times current equals power. And that's going to tell you how many watts your solar power, or milliwatts, your solar panel is producing. Both the current and the voltage, super important, because that's going to tell you which loads you can power. And some of your loads will tell you its needs right on the back. Like this is a 6-volt buzzer. I don't know what the DC motor is, but when you purchase things, sometimes it'll tell you what the electrical needs are of the various loads. Once you've played with one solar panel, you should definitely hook up the second solar panel to see how that changes things. And again, this is where your knowledge of series and parallel circuits is going to come in. So when we're talking about the load side, if we connect both solar panels, black to black, red to red, you'll notice that our current, which is what I was just measuring, doubled. But if we go back to the voltage reading, it's the same as it was before. So in parallel, we're going to amplify the current, but not the voltage. But if we change this and connect them in series, which now has this going in a loop all the way around, so they're like holding hands, you'll notice that now the voltage has doubled. But if we go back to current, the current is now the same as it was with one solar panel. So that is an important thing for your students to investigate and understand before they try to figure out what they're going to be able to do with their solar panels. And you could always add another solar panel. Remember, there are safety restrictions for the challenge, but you can still add a couple more solar panels before you get to that level. So that's getting to know your solar panel. So we're going to move on from there to powering each of the loads. So what we have here are lots of different things that the students can power. So this one is by far everybody's favorite. This is a water pump. The tray allows you to put some water in there. I highly recommend, if you're going to pump water, that I would do a self-circulating pump as opposed to like putting it somewhere, because with limited amounts of water here, you're gonna run dry pretty quick. So usually I just kind of recirculate the water around. It's a lot harder to pump up a hill than it is to pump around in a circle. So there's a couple of reasons why that tends to be a good starting point, is to just kind of recirculate it, see what they can do. This is a basic motor, DC motor, so when we put the solar panels black to black and red to red, it's going to spin. If you were to do black to red, red to black, it would spin in the opposite direction. Always challenge the students to figure out how to make it go backwards, and then envision what could this motor do? What problem could you solve? Could it be a car? Could it be an elevator? Could it be a ceiling fan? Like, what could that be? And then of course the pump could be many different things, right? It could pump water into a cleaning device. It could pump water to make a pretty water fountain. It could do lots of things. This guy here is the most annoying thing in the world. It is a buzzer that is, you'll definitely want to move quickly to how to use a switch, because it's very annoying. But one solar panel connected red to red and black to black is going to make this guy buzz. These are pretty delicate. The wire strippers are helpful because sometimes the wires do come and break off, and so you just have to restrip those wires to give yourself something to clamp onto. Okay, so red to red, black to black. I don't think we have enough ambient light here to make that buzz, but that's a pretty simple one. The last thing that you have in your kit here is a basic LED. The key with LEDs, right? They are light emitting diodes. The electrons have to move in a certain direction in order to make the light light. So it's very important. You have a long leg and you have a short leg. The long leg is the positive, so it needs to be connected to the red, and then the short side is the negative, and it needs to be connected to the black. And then again, I don't think I have enough solar energy in this room right now, but that should light the light bulb. Okay. So you've got lots of possibilities, and of course you can go out there and use your snap circuits and your little bits and anything else that you want to power with solar. You're not limited to these loads. The other thing that you have in here is a switch. This switch is a pretty basic switch. The idea being, if you connect your circuit on either side, this will open and close your circuit. So I will wire this basic real quick for you so that it's easy for you to see how we would do this. Okay, and I'll use the motor as an example. So if we were to power the motor, we would go red to red and black to black. And this is the basic circuit. If we wanted to add the switch in, we're gonna need an alligator clip, and we need to break open the circuit. So at this point, the electrons can't flow, and that would shut off. So instead of doing that every time, we're going to insert the switch. So all I did was break open that negative side, all those black wires, and I added this alligator clip in. This should still work. But if we want to add the switch in, we're going to separate the two alligator clips, clip them to opposite sides of the switch, and now when we open and close the circuit, the motor should go on and off. Again, it's not demonstrating because I don't have enough light right now in this room to make it work, but that's the basic setup. And you can make switches out of paper clips and brads and index cards or aluminum foil. They're real easy to make. There's lots of variations of switches. We have these sliding switches that we've used in the past, button switches. Anything that you can find from an electrical store is gonna work with solar panels. So I highly encourage you to take this kit and power everything, then try to power multiple things at the same time, and then add the switches in various spaces to really get to understand how to build that complex circuit. Again, remember, for this challenge, the key is your electrical diagram. So I just made a couple of really simple electrical diagrams that show one solar panel lighting 2 light bulbs in parallel, and then this one shows one solar panel lighting 2 light bulbs in series. So your electrical diagrams will look way cooler than mine, but just remember, having your kids diagram their simple circuits in the beginning and then having them add complexity to those circuits and the circuit diagrams will help them get to that final place where they're bringing something awesome to that challenge day. If you have any questions about how to take this further or where to get more gear, please feel free to email us at casejmu@gmail.com, and I look forward to seeing you in an event.